Hi guys and welcome to my channel. In this video my topic is linear programming. This is something that's covered in Form 4 and sometimes in Form 5 and it's done in math. So in this video I plan to, as usual, cover some past paper questions and some other difficult questions based on this topic and go through the detailed solutions. So stay tuned to what I have in store. Now, one definition when I searched up the linear programming was that linear programming is a method to achieve the best outcome in a mathematical model whose requirements are represented by linear relationships. Okay, that's all well and good. However, my definition of linear programming is simply you will need graph paper, you will be doing up on X and Y axis for each question, and there are going to be various lines, linear lines on this graph paper that we're going to draw. Also, you will also need to be familiar with inequalities, graphical inequalities. For example, say we have to draw up the line where x is equal to 3, and say that line was here. So then we will draw a vertical line going this way. That will be the line x is equal to 3. We need to be familiar, you need to remember, where is the section of this graph where x is less than 3 and x is greater than 3. Now it will obviously be here, where this is where x is less than 3, and on this side here will be where x is greater than 3, right? So we need to be familiar with how to identify these sections on our graph for this topic, right? Now what would happen is, in a typical question, this is one line, yes, that we would have to produce on a graph paper, but there may be two other lines. So in all, we usually have 3 lines on a graph question, right? And so we will have 3 sections that we would have to shade. And at the end, we would need to figure out where is the common region then between all 3 sections, and that is where we will yield our answers. Anyways, the best way for me to describe this is obviously with a question. So my first question is going to be an actual past paper question from CSEC, and I plan to dissect it. So let me start. Example 1. Now it says here, a school boy buys X balls and Y bats, right? So the first thing you should write is let X represent balls and let Y represent bats. So you must always write a statement like this, right? But of course you're sticking the words represent, right? The total number of balls and bats is no more than 30. Write an inequality to represent this information. So that just simply means X plus Y must be less than or equal to 30. So that will be 2 marks for this. The second part now says the school budget allows no more than $3.60 to be spent on balls and bats. The cost of a ball is $6 and the cost of a bat is $24. Write another inequality for this. Well, this will be then 6 by X plus 24 by Y must be less than or equal to 360. Right? Now, of course, even though you're given this inequality or you figure out this inequality, you can simplify and divide by 6 or whatever it might be. So we'll get X here, we'll get 4Y, and we'll get 6 there on the side. So this is the better inequality to work with. But of course, you make sure and show them this blue one also, and then you show them how you got this red one. Right? The reason why you want to get a simplified inequality is because you want to be able to have smaller values so your graph is not that big, right? Okay, so now moving on in this question. So with these 2 inequalities now, that is this one here and this one here, right? We could go to graph paper. So they give us some instructions here now. They said 2 centimeters represent 10 balls and 2 centimeters represent 5 bats. On each axis, they want us to put in these 2 inequalities, right? And then shade the region and also add in these other inequalities. And those inequalities are X is greater than or equal to 0 and Y is greater than or equal to 0. So we actually want to incorporate 4 inequalities in this graph. And they said use your graph to write the coordinates of the vertices in the shaded region. Now they didn't tell us where to shade or not, right? So perhaps they probably mean that we want to shade the region that we want, right? Because they said the vertices of the shaded region, right? So now let me go to the graph question, meaning the graph solution to this part, right? Now, say this is our graph. They said they want us to be 2 centimeters represent 10 units and 2 centimeters represent 5 units on the y-axis, right? We have to put in these regions. X is greater than or equal to 0 right? So x is greater than or equal to 0. This is a line where x is equal to 0, this whole y-axis line. So where x is greater than or equal to 0 would be, well, sorry, that's the line where x is equal to 0. So greater than or equal to would be this side. So I'm going to put in the shading for this section here. So this is what we want, all of this. Now repeating this process now for y is greater than or equal to 0. That again would be the x-axis this time. So that'll be this line here, like this. Right, that's, remember there were 4 inequalities, right? First one is x is greater than or equal to 0, then is y is greater than or equal to 0, right? So where y is greater than or equal to 0 will actually be above here, right? So that's the section that we do want. Remember in this question they want us to shade the region that we do want. The third inequality was x plus y is less than or equal to 30. Now according to this would mean that this point here, that is 0, 30, is 1 point on the graph, and this point here, 30, 0, is another point on the graph, because when x is 0 we'll get y is equal to 30, and when y is 0 we'll get x is equal to 30. So now taking a straight line here now and connecting these two, this is the line that I will get for that line, right? And of course it could extend further out if you wish, right? So this line is the line x plus y is equal to 30. This is an easy line to get. Now we want where it's less than or equal to 0. So that is actually lower down. That's actually below here, right? This is where x plus y is less than or equal to 30. Above here is where x plus y is greater than or equal to 30. And that's the thing with lines, guys. When you're doing linear programming, remember, if you have, I just do this at the side here, an x and y axis like this, and you have a line going this way, say, above is always greater than and below is always less than. So if your line is going that way, that's the rule. Now what if the line was going the other way? Say it was going this way. Again, the rule is the same. Greater than is above here, and down here now is less than, right? Okay, but anyway, with these examples that I'm going through, hopefully that will stick, right, with you. Now we did three inequalities. We have the third one to do now. This one will take a little more work. This one now is x plus 4y is less than or equal to 60. Now what I tell students with a question like this, right, what I want students to do is substitute any values of x and y, right? So say for example, let's say x is equal to 2, right? So then we'll substitute here for 2 plus 4y. Now we'll put the equal sign instead. 4y is equal to 60 minus 2, which is 58. Y is equal to 58 divided by 4. Just regular algebra we're doing here. We're getting 14.5. So 1 point is 2, 14.5. Now you could repeat this process with another value. Say x is equal to 4. 4 plus 4y is equal to 60. 4y is equal to 4y minus 60. That's 56. Y is equal to 56 divided by 4, 14. So our second point is 4, 14. Now let's just plot this point and this point on our graph and see what we get. I'm just going with another color. Right, so 2, 14.5. Now this is actually according to my graph. Now my graph is not the correct scale like what they say for the 2 centimeters and so on, right? Because I snipped this from the internet, right? To get this graph page, you actually have to use the regular graph page and divide it up, right? Now I divided here into 4, so I'm getting here is 2.5, here will be 5, here is 7.5 and 10. So 2 will actually be a little lower here. 14.5, this now is counted in, well, 1. So 14.5 would be around here. So 2, 14.5 is that point there. And then 4, 14 might be around here. So say something like this, guys. So now let's extend this, connect these two dots with a straight line. Say something like this. Right. Yeah, say something like that, right? Now, what do we want? Now, this is the line x plus 4y. Let me just erase this. This is 4x plus 4y is equal to 60. So we want where it's less than 60. So that's actually below here. That's what we want, right? So the common region, now you see all the different colors here. This is why I don't really like to shade the region that we want. I prefer to shade the region that we don't want because I find it's a bit clearer. But anyway, the section that we're seeing all the same colors for is actually here. Let me just go with this color here. Right, sorry, put on. Okay. Right, and all of this is in a shape like that. Right, so this is the section that we do want. Now the next thing we have to do is identify the points here. This point here would be 0, 15. We could call this A. We could call this one here, that would be what, 20, 10. That's B. This one here we could call this C, which would be 30, 0. And this point here is D, called 0, 0. Now this is usually what you have to do. When you get your feasible region or your common region, you will tend to find all the corner points, right? So we got 4 in this case. Sometimes it could be more, sometimes it could be less, right? So with these 4 points now, we could work out the profit. So let me go back up to this section with the profit and we'll figure that out. So now that we've done the graph, right, that's great. We have got identify about 4 points, right? A, B, C, and well, D is 0, 0. 0, 0 will yield us nothing. So we're not bothering to list 0, 0, right? So now they say the balls and bats are sold to students and they make a profit of $1 each and, well, $1 on each ball and $3 on a bat. So they have an equation here. So P is X plus 3Y. That's the profit equation, right? Use the coordinates of the vertices above to determine the profit for each combination and hence determine which is the maximum. So what you're supposed to do here now is that in A, X is 0 and Y is 15. In B, X is 20, Y is 10. In C, X is 30, Y is 0. Substitute these into this equation here each time and get the profit for each point. So for A now, the profit will be 0 plus 3 by 15, which would be 45. For B, the profit would be 20 plus 3 by 10. So that's actually 50. It will work out to be. Oops. And here, the profit here will be 30 plus 0 by 10, which would be nothing. So that profit is 30. So which one yielded the highest profit, guys? Well, that will be the profit of 50. And then you will say, well, you have to sell then 20 balls and 10 bats to get a profit of $50, right? Example 2. Example 2. A boy finds that he can pick no more than 20 kilograms of oranges and no more than 16 kilograms of grapes a day. So saying that we're counting oranges and kilograms and well, grapes and the kilograms for that, that means that we can define our two variables. So from here, I could just write the lines. Let X represent the kilograms of oranges picked and let Y represent the kilograms of grapes picked. Now, this first line here actually gives us two more inequalities. And that means that X must be less than or equal to 20. And Y must be less than or equal to 16, right? Now, they say in the second line, however, he is told that he is not allowed to pick more than 30 kilograms of fruit. So X plus Y must be less than or equal to 30. So 1, 2, and 3 are the inequalities that I am now going to go to graph paper for. However, reading the last line, they talk about wages. In this last line, they're saying that he will get $3 for every kilogram of grape and $5 for every kilogram of oranges. So that means that the wages will actually be 5x plus 3y, right? So now let's move on to graph paper. Now once you have the graph page, first thing you need to do is say, let this represent the kilograms of oranges, right? That axis, x. And then here, let the y-axis represent the kilograms of grapes. Right, now, going back to our inequalities, it was x is less than or equal to 20, y is less than or equal to 16, and x plus y must be less than or equal to 30. Now, putting in this first line, we will get, right, this is a line where x is equal to 20, right, this line here, x is equal to 20. We want where it's less than or equal to 20, which is actually here. But in this question, since it didn't specify and tell us what region to shade, I will then shade the opposite side, so here. So then you could also write in as well, shading the opposite regions so that your examiner will know. Right? Okay, so now let's move on. So this is the first inequality. Let's deal with the second one. Y must be less than or equal to 16. So let's identify where y is equal to 16, which is 1 unit above 15. So that's here. So this is where y is equal to 16. So less than or equal to is obviously down here. So I'm going to show the opposite, which is up here. So this is where y is greater than 16, and this again is where x is greater than 20. Just sticking in those inequalities. Now we need to find out for this line here, x plus y must be less than or equal to 30. Now the first thing you should do is take out the inequality sign and put x plus y is equal to 30. And then you could substitute two values of x. Say x is equal to 0, you get 0 plus y is 30. So then y is 30, 0, 30 is 1 point. So that's actually up here. Now say x is equal to 1, then you get 1 plus y is 30. So then y is equal to 30 minus 1, which is 29. So the next point is 129, which is actually right here, like that. Connecting these two blue dots, putting in a blue line as well, I will get a line going like this, something like that. Now, of course, it will be a lot easier for you all because you're just using pencil and ruler, right? Mine is not perfectly correct. So just trying to fix it up here. Right. So, from here now, right, so this is a line where x plus y is equal to 30. But I want where it's less than or equal to 30. So that's actually down here. So I'm going to shade the opposite region. So that's up here I'm going to shade. So this is the section where x plus y is greater than 30. Right? So now, let me identify the feasible region or the common region between all these, well, these three inequalities. That's actually this section here, 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 and here. Nice. So from here now, you identify your points. First point, we could call it A. Could be here. B could be here. C could be here. D could be here. And well, E could be this corner here. You can label this however you wish. Now going back to the the wages equation, we got that the wage must be 5x plus 3y. That is the wage. Now identifying our 4 points, we get 0, 16. B is 14, 16. C is 20, 10. D is 20, 0. We are going to substitute these 4 values into this wage equation. Now, once we substitute these 4 values into this equation, we are looking for which coordinates will yield the biggest wage.
Ends up being C, right? So when I put in C, which is x is 20, so I get that, plus 3 by y is 10, I'll get 100 plus 30, 130. Now, when I do it for each one, you will see that this value is the biggest out of all 4. So then you would say that the wage, to get a wage of 130, which is the maximum wage, he would need to pick 20 kilograms of oranges and 10 kilograms of grapes. So I hope that you all understand with these examples, and I hope that this video was useful to you all and that this topic is a little less intimidating. Thanks for tuning in. Please feel free to like, share, and subscribe.